Project code ITPW50. Project title: Design and Development of Modified Bridgeless Blue Converter for Power Quality Improvement in Electrical Vehicle Charger. Generally, in electrical vehicle charger, input is AC input, but in dead end we are using the car battery. We have to store the DC voltage, so the conversion takes place like AC to DC conversion. But this only transfer is not enough for the battery or e-vehicle battery charger. We need some other concept which will implement in the e-vehicle, some other norms which will follow for the battery storage in a e-vehicle. In a conventional concept, the AC, generally AC is getting 220 or 230 volt AC, which will be converted into DC by using diode bridge rectifier. The diode bridge rectifier is used, which will be given to the buck converter, but in because the buck converter used to reduce the voltage from the 222 like 48 or 64, depends upon the battery capacity which will use in a e-vehicle. It will store in a battery. It is a existing concept. But in existing concept, while using the diode bridge rectifier, which will increase the conduction loss increases when using the diode bridge rectifier. It also increase the ripple content in the input current. So these are all the main drawbacks when using the diode bridge rectifier. And also in a conventional buck converter, we use it is a non-isolated converter. Here the isolated converter is mainly used because the isolated converter provide the galvanic isolation. That means actually battery in a car which have to be safeguard from the input side. In case input having any problem, any fault means it is not affected to the battery. So the isolated converter like flyback or push pull converter which is used before the battery, this will also safeguard the battery from the fault from input. So it provides the galvanic isolation. So the proposed concept, the AC input in an electrical battery charger, it will given to the bridgeless loop converter, because a bridgeless loop converter have the capable of increase the voltage and also convert the AC to DC without using existing diode bridge rectifier, and again using the isolated converter like flyback converter. Because instead of using the existing boost converter with the loop converter, means because loop converter have the capable of increasing the voltage when increase the gain when compared to the boost converter, and also reduce the current ripple also. So the loop converter technique is used instead of the existing boost converter. This flyback converter provide the galvanic isolation. It will given to the battery. This is a proposed concept. Proposed concept using it will reduce the, it will correct the power factor in the input side. So we will get the better power factor, and also the better power factor will also reduce. It will improve the THD, and the size also reduced when compared to the existing system. And this in a flyback converter, the current and voltage controller technique is used. So we get the it will help to get the constant current and constant voltage for the battery charging. This is a proposed block diagram. Mainly this concept is used in an electrical vehicle application and battery storage application. This concept is implemented in MATLAB 2015b version, and the microprocessor lab which is used to give the program to the PIC microcontroller in a hardware prototype. These are all minimum hardware requirement. Power MOSFET, transformer, PIC microcontroller, and other active and passive components are used. Thank you.